Welcome to a Triple Helix Robotics instructional video series, Building a West Coast Drive. In episode 6, we'll be cutting gearbox plates using a laser cutter. And the skills that we will learn in this episode, first thing we'll do is export a DXF file from CAD. Then we will position the stock on the laser cutter and set the laser cutter head so that it will cut the parts out properly. Then we'll turn on the laser cutter and let it cut the parts. And then we'll take those parts back to the shop and deburr them. So let's get started. So what we have here is the gearbox that we used on our competition robot this year. And the two side plates are made out of delrin. They're laser cut. And Justin is going to use Creo to create a drawing and then of those two side plates, and then we're going to export that out as a DXF and then bring it into the laser cutting software that we use. And as he does that, he's going to explain to you guys what the settings are and what that process looks like.
So the first thing we need to do is create a new drawing. So it's best to have the assembly open while you're doing it. That way they'll automatically get in the list of things you can put in the drawing. So we're just going to call this GBX gearbox tutorial. And then just use empty and then variable. So we want this is in inches right there. So the width of them is probably not above 10 inches or something, so we could just do like 10 by 10. That should work. It really doesn't matter, it just needs to be big enough that it can fit inside of it. Hit drawing models, and then click add model, and then we need to find the two plates. So the first one is called inner plate, and then we'll open that, and then we need to hit general view, and then hit OK, and then click anywhere on the screen, and then choose front orientation, and then click OK, and it's just appeared there. So now we need to put the other one in. So we're going to hit drawing models again, and we'll add a model and go to motor plate, and then we'll hit general view, and then hit OK, and then click anywhere, and then click front again. So now what we can do is unclick the lock view movement. That way we can move them around. So we want them to be as close as possible so we don't waste any material. So this should be good right here.
Do you need to adjust the scale to be a 1-to-1 scale?
Oh yeah, I forgot about that.
Yeah.
Thanks for telling me that. Okay, and is it drawing models?
Yes.
Set model.
Select, and you've got to select the other one. There you go. Now you can change that view.
There we go.
Yeah.
Okay. So now what we need to do is, I forgot that we were putting both of them together, so I need to make it a little bit wider. Properties. Okay, there we go. So we want the width to be probably 20, so just double. And there it fits. So now what we need to do is just move it all to the middle. So as close as possible again. And usually parallel if you can get it. And this looks good enough. So now what you need to do is make sure that all your data features are turned off. That way they don't show up in the DXF. And then you want to click wireframe and then zoom, so then it'll create a wire. That way it'll know where to laser it. So now what we want to do is, first of all, just save this, and then save a copy, DXF, select DXF. Now click OK. Now just said OK, ignore that stuff. So now it should have it saved. So if I go in here, it's already showed up here, and then there's just a log there. So now we can just close all this.
Now before you close that stuff, can you go to the model of one of these plates and check and see what the dimension of the bore hole is for the bearing? So the final dimension should be 1.125, but the width of the laser cut is 10,000ths of an inch wide. So if you model it as 1.125,
it's 1.12.
It's going to be too big. So what does it say it is?
It's 1.12.
It's already been sized smaller so that when we cut it with the laser, the hole ends up at the right size.
Alright, so now I can go ahead and open LaserCAD, which is the software we use for our laser cutter that allows us to import files and then laser cut them.
You're opening up that DXF file?
Yeah. So there it is. So we're going to click that, and then first thing you notice is it's insanely small. So like I said, we have to change the scale.
So we exported it as inches. It's importing it as millimeters.
The first thing we need to do is select all of it, and then we need to hit the lock button, and then we need to open a calculator.
What does the lock button do?
It locks them both, the width and the height together, so it scales them right. So we want to do 13.516 times 25.4, which is the conversion factor. So that's 343.3064. So we can go ahead and delete that, and then you can't Control V for some reason, so you have to paste. And now it's the right size. So now the thing we need to look at is our settings. So depending on what thickness we're using, we need to change the speed. So this thing is made out of 1/4-inch delrin.
Yes.
So let's find it here. I think
That's
it's
acetyl delrin right there.
acetyl, okay, which I think it's 0.25. This one. So the speed is 3 millimeters per second. So we want to click on that and then change this to 3. And then these are really the only settings we really focus on. So you want the max power to be 100, and so you can hit OK. And then next thing we want to do is actually go over to the laser cutter and then plug it in, and then we can download it to it. Another thing you might want to do, it's optional, is just save the document. So I'll just, if you ever want to laser cut it again but don't want to have to re-import the DXF, so I'll just call it GBX tutorial again.
So we got this pulled up next to our laser cutter. So we need to grab our USB cable and plug it into the computer. So it should be connected now. So
Now, is there any particular mode this has to be in for it to work right?
no, it can be like this. It's just fine.
Okay.
So now we just click download right here, and then just click download document. And now it popped up right there. So now we can go ahead and unplug it. It doesn't really matter now. So we have the delrin on there right now, so we don't have to do anything.
Right.
So the first thing we need to do is get our safety glasses on. So get on here. So what we need to do is position where this is going to go on there. So you want to probably put it over on the left side, the left back, because that's where the mirrors are closest, and then it'll be more accurate. So we need we can use these to move it around.
Yeah.
And we can use these two buttons, the origin and the box button. The origin just sets the origin.
And where on this picture is the origin? Is it that blue dot?
Yes. So
Okay.
if we click the origin, it's gonna do it over there.
Okay, so you're gonna move the laser to where you think that blue dot corresponds to and hit origin.
Yes, so I already got it in the right place, so I'll just hit origin and then hit box, and then it'll move in a box.
So it's drawing a square around where it thinks it needs to go, right?
Yeah. Did it stay in?
Yes.
Did it stay on the material that time?
By about that much.
Okay. So you moved it, and now you hit the box again, right?
Yep. So this is probably the best we're gonna get it.
About 3/4 of an inch.
Yeah.
Now that we have it positioned, now what are you gonna do?
We're just gonna hit start. So.
Okay, so when we hit start, that laser is going to come on, and anybody that doesn't have laser glasses needs to turn around and face the other way.
3, 2, 1, start. Start your mouth recording.
now that we're back, you've got your parts. So now you need to wipe them down and punch out any of the little holes that are left. Might need something with a hammer and a punch.
There we go. Came out.
Yep.
So now what we want to do is deburr these holes. So,
Okay.
Deburr and make sure it's locked by twisting it counterclockwise. So the way we do this is you always want to be pulling towards yourself.
Mm-hmm.
So we just take it and then so if we're doing the circle, we just rotate around and pull it toward ourselves like this.
Okay, now that you're getting close to done, grab a bearing and test the bearing holes to make sure that
They don't go in.
they fit.
Let's see if it fits, right?
Fit good?
Yeah.
Great.
Fits in both.
Good.
This one's better than that one.
Yeah.
It's actually tighter.
Mm-hmm.
Try both sides.
And sometimes one side's tighter than the other.
That one's really tight.
Okay. And that's because the laser, when it cuts, it doesn't cut perfectly straight. It cuts at a little bit of a cone.
Yeah.
Did you check both fit, or did you check both holes? So I think those plates are done.